Hello everyone. We know that 1 plus 2 is equal to 3, 1 plus 2 plus 3 is equal to 6, 1 plus 2 plus 3 plus 4 is equal to 10, and so on. It is clear that each term on the right hand side is a positive integer, and the terms keep on increasing as we add one more term to the left hand side. We are interested in looking at the sum of the series 1 plus 2 plus 3 plus 4 added to infinity. Let us take S to be the sum of this series. The question is S negative or fraction? You would promptly say that no, it is not possible. My claim is that S is equal to minus 1 by 12. What would be your first reaction? Do mention it in the comment box. In order to prove that S is equal to minus 1 by 12, I am making a claim. Claim 1 is S1, which is the sum of the series 1 minus 1 plus 1 minus 1 plus 1 minus 1 added to infinity, is half. So we have S1 is equal to sum of this series. If I take a negative sign common from the second term, third term, and so on, I get this expression. If you look at the expression in the parenthesis, it is S1 only. So S1 is equal to 1 minus S1. Simplifying it results in S1 equal to half. This establishes the claim 1. Now my claim second is S2 is equal to the sum of the series 1 minus 2 plus 3 minus 4 plus 5 minus 6 plus 7 and so on is 1 by 4. So we have S2 equal to the series. We can write S2 in this way. So the first term of the series is under the second term and so on. On adding the above equations, we get 2s2 equal to 1 minus 1 plus 1 minus 1 plus 1 minus and so on, which is nothing but s1 equal to half. This implies s2 equal to 1 by 4. This establishes the claim second. Now, given s is equal to 1 plus 2 plus 3 plus 4 plus 5 plus 6 and so on, we are interested in the sum s. Also, we have s2 equal to 1 minus 2 plus 3 minus 4 plus 5 and so on. If we subtract the second equation from first equation, we get s minus s2 equal to 4 plus 8 plus 12 and so on. Taking 4 common, we get 4 into 1 plus 2 plus 3, and the infinite series within the brackets is nothing but s. So it is 4s. This implies minus 3s is equal to s2, and s2 we already know as 1 by 4. Hence, s is equal to minus 1 by 12. Isn't it fascinating? But it is mathematically incorrect. In order to justify that this derivation is mathematically incorrect, let me now proceed to a definition. The definition of convergent series. A series of real numbers a1 plus a2 plus a3 and so on added to infinity is said to be convergent if the sequence of partial sums, that is the sequence a1, a1 plus a2, a1 plus a2 plus a3 and so on, is convergent to a real number. Now going to the claim 1 again. We had already proved that s1 is equal to the sum of this series, which is equal to half. Now there is error in this claim. If you look at the sequence of partial sums, it is 1, then 0, the sum of the first two terms, then sum of the first three terms is 1, the sum of the first four terms is 0, and so on. So you get a sequence 1, 0, 1, 0, 1, 0, which is clearly not convergent. Hence, the claim 1 that s1 equal to half is incorrect. Similarly, if we look at the claim second, which says s2 equal to the sum of this series equal to 1 by 4, there is again an error in this claim. If you look at the sequence of partial sums in this case, the first term is 1, sum of the first two terms is minus 1, the sum of the first 3 terms is 2, the sum of the first 4 terms is minus 2, and so on. Sequence 1 minus 1 2 minus 2 is an oscillatory sequence which is not convergent. Hence claim 2 is incorrect. So the conclusion is manipulating an infinite series can lead to mathematically incorrect results. Thank you so much.